Good morning and welcome to Previsant's Payment Integrity Demo. My name is Doug Ramsey, founder and CEO of Previsant Insights, and we are excited to show you what we have developed in this space. First, just a brief overview of who we are. There are essentially three offerings that we have. One is strategy and enablement, and that's really a focus on traditional strategic consulting, helping clients understand their key drivers, their value chain, and then specifically where data analytics, machine learning, and AI can be applied to create value. The second is on our advisory and mentoring capability, and that's where we're getting engaged with clients to really provide senior leadership on an interim basis to help the client understand and the team understand where they're headed and provide direction on a daily basis as folks are being groomed for maybe that senior role, or really just trying to understand if the client wants to invest in that role long term. But most importantly, what we're here to talk about today are healthcare insights as a service, and very specifically payment integrity. And this offering is essentially working with clients to ingest data and solve a very specific business problem based on our pre-built offerings. So in the case of payment integrity, which we'll talk about, it's a combination of machine learning, generative AI, and traditional data engineering capabilities that help create an insight that's actionable for clients to work with. With that, let's transition into the Previsant payment integrity specific overview. And we'll start here with really the landscape in the industry. And I think probably not surprising to many, when we talk about payment integrity, and particularly payment integrity in the Medicare space, there's a significant problem and opportunity. CMS, or Center for Medicaid and Medicare Services, estimates about 7.5%, which would be conservatively 30 billion. The note here is that we also think this may be much bigger, and I think a lot of folks feel this could be much bigger than 30 billion, depending on if we're just looking at post-payment and payment errors, or if we're also looking at prepayment and fraud. So in its entirety, this could be 80, 90, $100 billion problem. Again, just in the Medicare and Medicare supplement space. What we talk about in terms of our product at a very high level, it's really combining a set of technologies, which is both generative AI to understand where the problem, or where the rules are, I should say, to use GenAI for rules extraction, and then also a machine learning capability to help understand what is likely fraudulent right up front. And not only that, but proactively understand where emerging schemes are and try to catch things before the horses are out of the barn. And overall, one of the things we talk about over here is, the current methods are very labor intensive. They're very reactive. They don't tend to discover things until it's much too late. In other words, the horses are out of the barn. So our intent is to combine both process innovation and machine learning AI to help provide a better solution. And again, we just at a very high level, the benefits are it's more holistic. It's not purely a technology solution. We also very much believe in integration with process and making sure these insights are actionable to get to value for the clients. The other key piece here is that we are practitioner driven, not just data scientists, but folks that have spent time in healthcare, financial services, and insurance throughout our careers, marrying data analytics insights in it from a practitioner perspective to very specific business problems. So one of the things we wanted to show here is just a demo and visualization of improper payments, which is going to be fairly familiar to a number of folks, but really the point here is just we're trying to illustrate the fact that this is not a static problem. The people that are perpetrating fraud are very good. They're very dynamic. They continue to innovate their programs and the way they go about extracting money fraudulently from the system. So the point here is it just shows year over year how that switches from durable medical equipment to other types of fraud schemes that continue to go on. So From a predictive perspective, we think the advent of machine learning is really, really critical to help understand and get in front of these problems before they become huge loss opportunities or huge drains on the system. So moving into the solution overview specifically, we'll just go left to right here. But the heart of the process that we have is really what we're calling the payment integrity engine. And its focus, its job to be done is to identify either fraudulent claims or miscoded claims. So again, this is really the heart of what we're doing. And we refer to this as our Previsant knowledge base. But in terms of its components, it includes a fraud, waste, and abuse prediction. So that's it, using a variety or a suite of ML techniques. It's also using rules extraction. So this is what we talked about previously, which is the universe of coverage documents from CMS specifically is the single version of the truth for how a Medicare policy or how a Medicare claim should be paid. And what we're doing is using our generative AI engine to extract the rules that are embedded in natural language inside of those documents and turning that into a set of testable criteria, essentially a data asset that then serves as a set of criteria for, or that can be applied to any claims data set. Also, we talk about emerging scenarios, which really is part of, again, the prediction to say going forward, how do we proactively understand what are leading indicators that would tell us that we have a new scheme that is starting to emerge so we can get in front of that. And then lastly, just the scenario findings. That's more descriptive in nature, but it's really producing something that's actionable for our clients to use going forward. So again, the big piece, the two big pieces here would be prediction is an actual insight that from an actionability perspective, the client can say, we believe this should be identified as at risk or a fraudulent claim, and then that enables an evaluation from a special investigations or a claims team. And then secondarily, the rules extraction piece is saying for claims that have already been paid, we believe these are areas that were paid incorrectly based again on Medicare's coverage. Now, the other piece we talk about a fair amount is we can move back and forth between, we don't have to wait for claims to be paid. We always want to continually left shift the outputs of this rules extraction process. But key thing we want to reinforce here is from a solution perspective, we are creating a data asset that can then be leveraged against a claims file to tell us what is and isn't or should not have been paid. Okay, moving into our actual demo content. This is essentially a visualization of the capability we just demoed or showed on the previous slide, where we're really focusing on the output of the GenAI enabled rules extraction within our solution, and then having that applied to an 837 or a paid claims data record. And so again, the universe, as we talked about on the previous slide, the universe of this data is essentially incorrect payment, right? So what we're doing with this visualization is showing what is the distribution of those incorrect payments identified by the engine, by article, by procedure, and diagnosis. And we note that up here. The other thing we need to be very clear on that this is synthetic data. And for obvious reasons, for HIPAA constraints, etc., even though we're showing this at a summary level, we do not want to use real data in any situation. So this is, to be clear, this is synthetic data that we're demoing here. But having said that, what we start with here is again the universe of paid claims. And again, the visualization does not support the hover over within PowerPoint recording, but what we're noting here is let me see if I can zoom in a little bit. I cannot. We're showing a paid amount and a number within that entire universe. From there, then the visualization simply decomposes First at the article level, which is the heart of the rule, and essentially the coding rule that Medicare has put into their documents that says these are the instantiation of the actual coverage rules for Medicare. That then further break down into within this universe, this is the number of articles, and you can see in this example, we're heavily skewed toward one particular article. Then within article, we can decompose that further into what the procedure is, and of course, procedure defines what was done, what procedure or what step was taken as part of a particular claim. Next is the primary diagnosis, and meaning the why, or what was the underlying diagnosis or condition that drove the procedure. And then we get into secondary, tertiary, etc. Diagnoses that may be associated with a particular claim. So again, in this case, what we're really demoing here is the data asset itself and the resulting outcome from our rules extraction, GenAI driven rules extraction engine. And here at the bottom, we're just, again, doubling down on the scope of the output. So it's claims identified as incorrect from a claims data set based on our GenAI engine, and then the visualization is showing distribution, starting with the overall inventory, articles within inventory, procedures within article, diagnoses within procedure, et cetera, et cetera. And from an actionability perspective, the reason this is important is it allows the client to do research and help prioritize how they think about which ones of these identified claims that they want to go after, either because of frequency or amount, etc. So that is the essence of the actual visualization demo that we're showing here, and hopefully that's helpful. So with that, we wanted to thank you all for taking the time to watch our demo. We are excited about the generative AI and machine learning capabilities, both that are inherent within our solution. We want to thank our partners at Microsoft, frankly, for their support with the Founder Portal and leverage of the Azure platform, which has been invaluable for us as we've developed this capability. So for myself, Brian Ng, Jana Hart, Satya, thank you again for taking the time. Feel free to reach out with any questions. You have our contact information here, and we would love to hear from you. Thank you, and take care. Bye.